Well, the Zarkos graph came from data that was taken from 40-odd ocean bed cores drilled over the last couple of decades in a wide-reaching program you can see on the map here. The idea is that investigators look for places on the ocean floor where sediments have been undisturbed for a long time, and the core should yield enough data to date the various layers in the core. And then from the mud they carefully extract these little things, the shells of planktonic organisms that lived sometimes tens of millions of years ago. Even though the shells are only the size of a grain of sand, they're remarkably durable, and specialists can tell from the species when they lived, whether they lived at the bottom of the water column, the middle, or the surface. And then, using radiochemical techniques, they can figure out the temperature of the water at the time those shells were formed. Now, this is a Zarkos record. Over on the right of the top one, you can see the scale in which those radiochemical analyses is represented. That's the ratio of oxygen 18, the heavy oxygen isotope, to the routine oxygen isotope. That tells a specialist what the water temperature was. Over on the left, using various adjustments, that's been turned into a global deep ocean temperature scale. And so the bottom graph gives us a picture of the world's temperature during those 65 million years. There's an enormous amount of detail in this record. I'll just point out a couple of its main features. The first one you can see is that the world warmed for about 10 million years until a peak at 50 million years ago. That's called the Eocene optimum, when it was 10, 12 degrees warmer than now. And then it began a steady cooling. At this point, about 34 million years ago, there was an important geophysical transition. A sharp cooling trend started the first glaciation of the Antarctic continent. So before that, when the graph is red, the Earth was essentially ice-free. After that, the Antarctic ice sheet had a fluctuating history and size and form until that point, about 14 million years ago, when another cooling trend began, which has essentially continued to the present. That's the beginning of the Pliocene ice ages that we're so familiar with. Now, if you think about the graph even a little bit, you'd have to wonder what on earth has caused the various twists and turns in this history. And this is where things become interesting. Investigators have been trying to figure this out for some years now, and this is the best kind of explanation that we have. That purple thing, this is a map showing where the continents were distributed about 50 million years ago. That purple thing is the Indian plate, which some tens of millions of years before that belonged to the continent of Gondwana. So it travelled right across that ocean basin. At 50 million years ago, it was approaching the much larger Asian plate, and then a solid collision between the two plates caused the uplift of Earth's biggest topographic feature, the Himalayan range and the Tibetan plateau. While the Indian plate was traversing that ocean bed, subducting large quantities of carbonate-rich ocean floor, it's thought that the volcanoes at the leading edge of the plate pushed the carbon dioxide in the atmosphere very high, high enough to cause the progressive warming. Once a vast quantity of new rock appeared at the boundary of those two plates, chemical weathering reduced CO2 in the air and induced the steady cooling. At 34 million years ago, another geophysical novelty had appeared. The Australian continent separated from Antarctica by a margin wide enough to open the deep Tasman Passage. In other words, there was a rearrangement of ocean currents and ocean heat transport, and it's thought that this was the event that triggered the formation of the original Antarctic ice sheet. And then at 14 million years ago, it's thought that the separation of South America from the Antarctic Peninsula was complete enough for the current Drake Passage to open and start the circumpolar current that now isolates Antarctica from the rest of the climate system.